Hello everybody, my name is Walter and this is episode 60 of my Redstone Commands Series. Commands like clone or fill allow you to control or manipulate entire areas within a game world. But sometimes that is simply not enough and you need to manually scan through an area. And today I would like to show you how you can do this easily using Minecraft commands. Now scanning is not overly complicated. All you need to do is start at a given point in the space and then step through the relevant dimensions in a given step size. In Minecraft, you usually do this in meters and just along the cardinal directions. If you just follow one direction, then it's a 1D scan or maybe a line scan. If it's 2D, then you're scanning along a plane surface. Or if it's 3D, you're scanning a volume, or you could also scan along a cone, as you will see in a moment. Now, you already saw an example for 1D scanning in the previous episode with raycasting. The only real difference to raycasting is that when you're scanning, you don't stop if you hit something, you just continue on usually until you reach the end of the area you want to scan. Because, well, you want to see everything that is interesting and not just the first hit. And with that said, let's actually have a look at the examples. So I've prepared 4 examples for different types of scan, and all will be centered around this armor stand here. So the first one is a simple 1D scan, and you can see it detects a block, and if it is an air block, it puts in a bubble particle, and if it's not, then a flame particle. Just so you can see the difference quite clearly. So that was a simple 1D scan. I will show you the code in just a bit, but let's go through the examples first. This here is an area scan of 2D, and you can see basically the same, just one line next to the other. Then we have a 3D scan, again centered around the armor stand, and you can see it detects not only these here, but you can also see the flame for the lever, and it would also be a flame inside of those other blocks here. And then finally, the more elaborate part, this would be a cone scan. Basically, ray tracing started from the point of view and just adjusted a bit to the left, a bit to the right, up and down. And each of those adjustments gets its own thing. And down here, I can actually change the direction it looks, so you can see how this is working. This might be actually a pretty decent approximation of a shotgun also. The closer you are, the more of these here will actually hit you and the more damage you will get. Just an example of how you can actually make use of this. Now with the examples shown, let's actually have a look at the code involved and explain what's actually going on. So let's start with the function scanning 0D. Now this function is called at every point of the scan and is the actual reason we go through the entire process. This is where the magic happens and where you can get creative. In my example, I'm just using 2 commands here. The first checks if the current position is an air block and then places a bubble particle. And the second places a flame particle in every other case. Obviously, you would have something else in here. This function is called by scanning 1D. Now I've hard-coded the scanning here, but you can use the same techniques I showed you in the previous episode for raycasting. So you can use an entity that is teleporting around, you can use recursive function calls, and you can use scoreboard objectives, MBT data, and so on to control starting and stopping points. But hard coding, I think, is a bit easier to understand if you know nothing about scanning. So anyway, how is this working? Well, I'm using execute position to change the execution position for this command. And I'm stepping in block increments through the x coordinate here. So from -3 up to +3. So it's basically centered around the current execution position. And that is where I am calling the function from before, scanning 0D. That's already the line scan. Now let's have a look at the 2D scan. And it's basically the same function. The only difference is I'm stepping through another coordinate, in this case the Z coordinate, and I'm calling scanning 1D. So I'm putting one line next to the other line and building up my plane. And 3D is again the same idea, just this time I'm stepping through the third coordinate, which in this case is the Y coordinate, and placing one plane on top of the other until I have my cube. And with that, it's time to have a look at the cone scan from before. So this function is triggered via the execute command as the nearest armor stand at eye level, and that is where the function actually triggers. The function itself contains 3 commands. The first changes the rotation to -10 in the first rotation, and then calls scanning cone with a max distance 5 and step size 0.1. Second command does the same, but with no change to the rotation, and the last one changes the rotation to +10 in the first. And if we now go into the scanning cone, you can see exactly the same basically. The only difference is now I'm changing the second rotation, and I'm calling scanning cone raycast again with the max distance and step size. This time I'm using the one that was used or given in the scanning cone init function. So very similar to what I did with the 1D and the 2D scan, now just with rotation instead of position. And then finally we have a simple raycast, which is pretty much the same as you have seen in the previous episode. So the only real difference is what happens when I find something. So instead of stopping with the raycast, I'm just continuing on. And if I find a block, I put a flame particle. If I only find an air block, I put a bubble particle. And unless I'm further away than the max distance, I then call the next step in the raycast, but I already explained how this works in the previous episode. And with that, we've reached the end of this episode about scanning an area. I hope you enjoyed it. I wish you a nice day, and well, see you.